Ready? I'll take it as a yes. All right. So welcome back to Cyber UC, everyone. Lots of exciting stuff this year, mainly the fact that we can't really be on campus. Go to my next slide. There we go. So if you haven't already, but you should probably all be in our Slack because that's how you join our meetings. Likewise, go ahead and join our Slack. Invite your friends to join. Invite their friends to join. Invite your family to join. We got a UC email. It's all good. Announcements and upcoming events. There's not going to be a whole lot this semester. We are redoing the Moz deployment in the lab, so we're probably just nuking all of the servers. We are nuking all the servers. And the only thing I could really think of that's coming up soon is NSA Codebreaker 2020. It's going to open in, I think, mid-September is when it opened last year. They don't have an exact date out yet. So for those of you who are new to the club, which I see one person definitely is, maybe Chad is as well. You might be thinking, what is Cyber UC? We're a student-run organization that do cyber things, which is pretty self-evident. So our local chapter of OWASP, which is the Open Web Application Security Project, which is a nonprofit for basically making internet sites more secure. We do pretty much nothing they do, though. We do more low-level reverse engineering and binary exploitation kind of things. Oh, so did someone join?
Yes.
All right, cool. I just hear noises, so. We also have a couple of our own projects. Like I mentioned earlier, we have our own lab. We also have a couple of software projects. So we have CTF tool, which is how we stage our CTF events. We just load problems into it and it throws up the server. And we have a competitive hacking team, which Chad is in charge of. It's our CTF team. We actually just played Google CTF and we got 2 or 3 points. And we're also part of the reason that UC remains an NSA accredited Center of Academic Excellence in Cyber Operations and Cyber Defense. So basically NSA looks at UC students and like, you guys are very good. And we say, we know. So they give us special treatment. Oh, wrong computer. So what are our goals as an organization? Basically just educate our members. We want to get everyone doing cool things. And that includes learning how to actually use technologies, getting good jobs, and talking to our industry partners so you can get good jobs. We also go around to local high schools, although it's probably not going to happen this semester. We also, like I mentioned before, support the NSA CAE certs for UC, and we get to do cool things that students on their own or through other clubs really don't get to do. Vitale and Northrop Grumman are 2 of our biggest industry partners right now. They hire pretty much all of our members, except for about 10% go to Siemens. We also went to DEF CON 27, which was the most recent DEF CON that was held in person. That was very cool. And if anyone has questions at any point, just interrupt me. I don't mind repeating myself. So other cool things we did is last year on the NSA Codebreaker Challenge, this is an open challenge to all universities in the United States, actually I think more than the United States, to come and do competitive technological challenges. We ranked 5th place, so there's usually 200 universities that compete. We were ranked top 5. Last year, the year before that, we were number 7, I think. Yes. So we're consistently going up. We're going to hopefully increase our score by a factor of 10 and catch up to North Georgia this year. So that's our goals. And just how our club is organized, we have basically our main meetings is what we're doing now. So that's under content. We have our lab, which is a physical place on campus that we can't go to right now. That's all under our lab committee and activities. And then we do recruitment, finance, public affairs, and outreach. That's outreach and recruitment are how we interact with high school students and other people at UC's campus. Kind of generically, they more or less blend together. Finance is basically one person right now, Chris Lopez, and he manages our PNC account. We get donations from our industry sponsors to keep doing what we're doing. And then we have public affairs, which is just maintaining our social media, which is kind of just pick me up for whoever's available, although if anyone wants to lead it, that's fine too. Noah Oki is currently in charge of that. Yeah, like I said, content's probably our main committee for the club. Make all of our club presentations and deliver cool demos, which I am currently instructing with the introductory slides. Get to research what's at the cutting edge of the field every week and then present. And if you can't learn anything or you feel like you can't learn anything in cyber, feel free to host a meeting because the best way to learn is to teach. So we all get where we are now. The outreach, we get service hours for teaching high schoolers how to hack things. What was our most recent outreach? Does anyone know?
I think it was Fairfield.
Yeah, I think so.
Yes. We went to Fairfield. We didn't take them Phone Adventure, did we?
No, we pretty much just presented on like what is cyber.
Okay. All right. So we take demos, we teach them how to do certain technical activities, and then we show them basically opportunities in the field and how they can get involved in things like this. Finance is, like I mentioned, just our finances. We have fundraising events, which historically were bake sales, which is now forbidden. So no on that, which is sad. Yeah, so any event we actually want to hold, basically finance has to put together, which is a non-trivial amount of effort, but it pays off very big because we have to do things like go to DEF CON, have other events, CTFs, public affairs. This is just our social media group, our hype crew. They keep people informed about us. So we have a Twitter, a Facebook, a YouTube. I'd say our YouTube is probably our most active social media right now, although maybe not recently, where we basically just try to spread the good word of cyber, connect with other interesting people, get new opportunities to do things. Lab. Cole, do you want to share anything in the lab?
Sure. Labs, honestly, most of it is getting redone. We're just kind of ripping some of the old stuff that didn't necessarily work as well as we would like out and redeploying those and redeploying that. So a lot of that's still kind of under construction. Unfortunately, we're no longer hosting weekly lab things because of Corona, and we have restrictions on who can actually be in the lab. But hopefully we'll be able to do some stuff later in the semester once things get redeployed and we can actually not necessarily bring people in physically, but give people access from. Oh.
Yeah, and just for people who don't know the exact details of that, we have 21 servers on campus, and we just replaced our power cabling for all of those. We've cut all of our network cables by hand, so there's a lot of fine-tuned control over that. We are currently replacing the software platform that we have in place to manage all of that because it was severely out of date because the way it updates changed from what we were using before. So we just went in and nuked the whole thing. We're going to basically rebuild a on-premise cloud from scratch, which is our lab. Wrong keyboard. So recruitment, you get to meet people around campus, tell them about cyber UC. Greg's actually no longer a recruitment head, so this is out of date. But yeah, previously when we could meet in person and it was easier to do things, we would have in-person events, board game nights. We used to play Smash in the lab because we have 2 giant TVs each end, bring our switches, other fun things like that. But now we, of course, cannot do that, but maybe we'll do some stuff virtually in the fall. So our schedule, this is our old schedule, because Monday evenings and Saturday mornings are not currently done. Unless we want to do CTF meetings. All right, I should check with this. So, as you know, yeah, you had Chad.
Yeah, I was more just going to, at some time over the weekend, each weekend going to just have different challenges or stuff like that for CTFs, or also getting a bunch of the different CTFs that are going on for people to join if they want.
Yeah, and I saw you were revamping our CTF time team as well, so we could also do weekly events that way, because there's always something going on in CTF time. If you're not familiar with CTFs, feel free to join us. They are very fun. It's basically hard technical problems that are meant to be broken, exploited, and hacked. All kinds of fun stuff. Wednesday evenings, so that's now. You get to bask in our Hive Mind's knowledge. Aaron is our current Hive Mind light lamp. So you get to bask in the light of his presentations. And then Monday evenings, we're going to try to virtualize this. We have our lab meetings, so we have our basically on-premise cloud at UC that we're overhauling. So if you want to do any cool projects with that, it's totally open to us. We have full control of it, like belongs to Cyber UC. So I'm sure most of you know this already, but what is cyber? If you ever said Keanu's my homeboy, you're in the right place. We do forensics, network security, penetration testing, security analysis, security architecture and design, cyber development, and basically anything you would associate with Keanu Reeves in the Matrix, except for like maybe flying around. But even then, we do hack video games. Like that is what we do. There's lots of money to be in cyber right now as well. So the average cybersecurity salary in Ohio is about 150% of what the average computer science salary in Ohio is right now, which is very good. There's also a huge demand for cyber jobs everywhere. So Ohio, specifically Cincinnati, is actually on the medium-high end of demand for jobs right now, with an average of 3 positionings per one candidate that can actually, or looking for a job. Yeah. And this is also a very enjoyable job, so enjoyable job field. So there's not a whole lot of jobs where you get paid to go to training sessions where you hack video games. So I guess we didn't get paid. We just went to Battelle for a day and they fed us. But that was very fun. We went up to Battelle in Columbus and they put on a Unreal Engine based video game called Clone Adventure, and the whole point of the game was you have to hack the bosses to actually beat it, which is very cool. And we're hopefully going to be able to put that on this year as well for just us. These are our projects. I'll kind of breeze through these. So I mentioned CTF tool earlier. This is just something we have on our GitHub that we can, or GitLab, that we can give our CTF problems to that we've made or that we've solved and reverse engineered back into usable problems that we can build. This is how we host our RevUC CTF every year. So we actually use this for 2019 and 2018. I guess it was 2020. Yeah, 2019 and 2020. And we take this to high schools. You pretty much want to put on a hacking game. You just press a button and it just does it for you. It's very fun. Range Master, this is kind of mutating into well-nigh senior design, but this is more or less a crutch for our lab to do more things than Moz allows it to do. Moz being our software platform that we use for it. So one of the example limitations of Moz is you can't just arbitrarily throw a VM into the system. You have to boot from fixed.exe. Range Master can not only deploy pretty much any VM, it can deploy them in mass. So we can deploy something like 300 VMs in a matter of minutes. It's very cool. And breakdown, Aaron, do you want to explain this a little bit more?
Yeah. Breakdown is something I worked on over the summer and kind of just threw into the cyber repos. It's basically an automated malware analysis tool. So it's written in Django using their REST framework, where basically you can say, hey, I have a piece of malware, tell me things about it. So you can see on the left there, like, hey, give me the strings that are inside this binary, and then it'll give that back to you. But that's a really cool tool. It's still kind of in its infancy, but one cool thing about it is it takes all that data and you can like export it to a PDF. So you have like a really pretty document on everything you found in a sample. So that's really all it does at its current state.
Yeah, so we got all kinds of cool things we're making, a little bit of everything in there. CTF tool is just a standalone Python application. Range Master is started as a standalone Python application, and then it kind of morphed into a REST server that we made entirely from scratch, but it's all Python based. And Breakdown is actually like a real REST-based framework rather than what we've done with Range Master. In some of our other efforts as a club, we do websites, or we have a website, we do live streams to YouTube, or at least we did. Now we're just going to do stuff through WebEx this year. We also have our content, which is what you're experiencing now, although this one's not as terribly exciting as some of our other ones. We have to go to DEF CON and B-Sides. I think B-Sides Cincinnati was canceled this year, which is bad. Or I guess good, because pandemic, but sad. So it's a local local conference that happens in most major cities for cybersecurity things, like a mini DEF CON. We went to the last one in Cincinnati, which happened 3 years ago now. Went to DEF CON 27 last year. We go to multiple high schools a year, although we're going to have to rework that to be virtual if we're going to do it at all. And we get visits to and from industry every year, and also from government. So we've had NSA has come to do demos for us. Last time they were here, they brought original World War II Enigma machines, and we got to play with them. Like they were like actually from World War II, and they just let us touch them and do things. It was fun. We also have had Battelle come in several times. We have had Jan, I can't pronounce his last name, Zardis, who was the team captain for Shellfish when they won DARPA Cyber Grand Challenge. So they're one of the most well-known and probably like highest ranked CTF teams in the world. They have a tool called Anger that basically simulates an entire computer around a single binary, and he's one of the people who made it. And we got to invite him to do an awesome presentation. It's actually on our YouTube if anyone's interested. And then we do CTF events. We try to do 2 a year, and we're trying to make basically modules for our Cyber Ranger cloud. Probably referred to as the Cyber Ranger, the lab from now on. It's for defensive and mix offensive cyber, defensive cyber operations, so cyber defense exercises. So we all get on the same network and try to hack while defending each other. Hack each other while defending our own machines. And our club's relatively new compared to, say, like Radio Club, which has been around since like 1920. So we can fit our timeline in just a few slides. We started in 2017, just a few of us. Though we have grown since then, because now our Slack has 1,000 people in it, or 500 people in it. We have done a lot of high school outreach, so everything on the bottom here. The Southwest Science Fair Expo at UC was a high school event. We've gone to Loveland High School multiple times. We've gone to Fairfield multiple times. We've gone to a lot of high schools. Revolution UC Hackathon in 2017, we participated in. Our members made a few things. I don't think we won any prizes though. And we get to visit a lot of industry people because it's very hard to hire people with our skill sets. So we've been invited to Fortune Global, GE, Fifth Third. We've gone to all their sites. We've gone to Battelle up in Columbus. They actually invited us there for the entire day. It's pretty cool. We've gone to a couple other events. Back at Wars was in Dayton a couple years ago, I think. Yeah, I think this is Siemens corporate SOC that we toured in 2018. We actually ran a CTF at the 2018 hackathon. We've run one every year since then. We became an official UC organization in 2018. Did some more high school outreach. We got our lab equipment in 2018. Went to another SOC. The NSA came for the first time in 2018 to visit us, and then we played 2018's NSA Codebreaker. I don't think we ranked, but yeah, we did. We got 7th place on that one, and that was like pretty much entirely through the effort of this club that we even got like above number 50 on that. Yeah, so we've done a lot of high school outreach, which is most of the stuff on this page. Some of the stuff on this page. Ran another CTF. Battelle actually invited us up in Columbus, as I've said multiple times now, to do a day-long CTF, which is the video game that we hacked. We went to DEF CON 27 last year. CTF tool version 1 we finished last year, so we can use that for future CTFs, and it's pretty well maintained now. NSA visited us again last year in October, and then a month after that, we placed top 5 on Codebreaker. So now when they go around to all the Center of Academic Excellence sites, which are all the colleges with that accreditation, the presentation they have has us in the top 5 because they only show the top 5. Like Cyber UC, University of Cincinnati's in their presentation. And then 2020, as I mentioned, we got a awesome presentation from Anger, from like one of the original creators of Zardis. But then, yeah, as you can see in March, we had a little bit of a hiccup with our, everything. So now we're here in August. So hopefully we get to fill out a lot of things on this timeline for the next year. So it's always growing. there's plenty of things that didn't make this, but yeah. So that's our club. If anyone has any questions, I'll answer them. Otherwise, I believe Aaron has some slides to show us.
I do. All right, sorry, one sec. All right. Oh no, WebEx wants to grab both screens.
Show us both screens.
While we're in this weird transition, we do need everybody to sign in. I will send the link in the Slack, so please, or I'll just send it in the chat here on WebEx. So if you see it, please sign in. The university is asking that we just say who is in our meetings right now, trying to track people. And it's helpful for us to see who's an active member. So that will be coming your way.
All right, can you see my wonderfully wide screen?
You got the wide one.
Yeah. Is it legible at all?
Yeah, we can read the right side. It's just kind of small.
Okay.
Your
I could
wingspan is too wide.
I could unplug a monitor, but
Can you just join them through software?
Yeah, I guess I could. Oh, that's weird.
So if you guys are up for it at the end, we can just go around the chat room and introduce ourselves to each other. I see we've got a few more new people than I was actually expecting, so this is good. I'd like to get to meet you all.
All right. Can you see me?
Yeah.
Cool. All right. If you guys want to unmute yourselves, feel free. Is there anyone here that doesn't know about virtualization or virtual machines or anything?
Me. It's me. I don't know.
Okay. So one thing that we rely on pretty heavily in this club is virtualization to run different operating systems and do a lot of stuff. RangeMaster is based pretty heavily on this. So when we get into Schemaverse in a little bit, if you're running Windows, you'll probably want to do this in a Linux VM. So go ahead and pay attention. I also sent a message in general to download an Ubuntu ISO. If you plan on following along, I would go ahead and download that if you haven't, because it is pretty big and it takes a while. So without further ado, we'll talk about virtualization. All of that we've touched. So yeah, like I said, go ahead and download that VM or the ISO. And then if you don't have VirtualBox, go ahead and download that as well. You'll see something like this on their website. If you're running Windows, get the Windows one. Linux, get Linux. So, all right. What is virtualization? It's in its simplest form, it's basically a virtual representation of something. So it could be an application, a server, different storage types and networks. It's a pretty abstract definition. Mostly when I refer to virtualization, I'm thinking VMs, but it could mean anything really. One thing you'll notice as a club is we like to throw memes in our slides. So if you have any good CS memes, throw them my way because I could always use them for slides. So basically virtual machines, you can think of them as a tiny computer inside a computer. So with your traditional architecture, you would have a single operating system and you would run different applications on that. So got one computer. Whereas in a virtual architecture, you would have a virtualization layer. It's typically a hypervisor. And then you can emulate different operating systems or many different operating systems on top of that. So that gives you a lot of flexibility. There's also virtual LANs. So you can logically group different networks, but it's not actually physically segregated. It's just logically segregated. So why would you want to virtualize? Generally, you could consolidate servers. So if you wanted to run, say, 10 instances of a web app, instead of having 10 physical servers, you could run 10 virtual machines on one server. So that saves companies a lot of money because they can consolidate hardware. Increased uptime. Basically, if your VM goes down, you can just spin up another one. You can back things up easier, where if you have a whole entire VM, if you want to save that, you just export the entire thing. And also faster provisioning. So if you want to spin up, say, 10 more instances of your server, you just spin up 10 VMs instead of putting together 10 hardware servers or 10 pieces of hardware. And then specifically with cyber, you can use it for penetration testing. So you can see in our little picture here, there is an Ubuntu VM. I think it's running Kali. I'm not sure. It's running Armitage, but they have another Windows server that they are attacking. So it kind of just lets you run different operating systems if you want. And then also malware analysis. So you can take different pieces of malware and throw them in a virtual machine and let them run, and you can kind of sandbox them to not infect your actual computer. So to actually virtualize something, you need a hypervisor. We'll talk a little bit more about that in a second, but some of the heavy hitters are VirtualBox, which is what we'll use. It's free. VMware is pretty nice, but it costs money. Hyper-V is Microsoft's version, and then QEMU and KVM is another hypervisor. We probably won't talk about that too much. So hypervisor is basically what runs your virtual machines. There's two different types. There's type 1 and type 2. The type 1 is commonly known as a bare metal hypervisor. So that basically runs on the hardware. It's typically faster because, as you can see in the type 2, there's that operating system sitting in the middle. So it's a middleman. So type 1, bare metal. Type 2, you have the OS sitting in between the hypervisor and the hardware. VirtualBox is a type 2 because it sits up in user space. So whenever your VM wants to, say, write to a file, it has to talk to the hypervisor, and then the hypervisor has to make a request through the OS, and then the OS will let that hypervisor talk to hardware. So typically you want to aim for type 1 if you can, if you want speed. We'll talk briefly about VirtualBox networking just because it's kind of important. So like I was saying with malware analysis, you can sandbox a VM. So that would be this not attached mode where basically it'll tell your computer, hey, here's a network card, but you have no internet connection. So your malware can't get out and talk to your host machine. There's NAT, which is network address translation, which basically hides your internal network. There's NAT network, bridged. I've never used NAT network. Bridge will basically do what it says. It'll bridge your VM to your network, so you won't have NAT in between it. There's also internal and host only. I've never used internal, but host only is nice if you just want to create a network between your host and different guests. We might use that a couple times. If we do some CDX stuff, I think we can use it. But anyway. This is a nifty little table to indicate how machines can talk to each other. I won't go too in depth into it, but this is also on VirtualBox's website. So if you've got a VM and you give it these different network modes, this just tells you whether you can talk to it or not from your host or different VMs, stuff like that. This is kind of dry material, so we'll try to move through it quickly. I think that's all. Yes. So if you guys want, I can deploy a VM and show you how to do it. If you've seen all this before, let me know and we can move on to Schemaverse. So is there anyone that wants to see me deploy a virtual machine?
I would like to see you deploy a virtual machine.
All right.
Show us, Aaron.
I can do, no, I don't want code. Go away.
Deploy a virtual machine from code.
No, thank you. All right, so here's VirtualBox. You can see I have 3 other VMs, but we're gonna start up a new one. So you can go to new, and we'll just call this Ubuntu. Okay. And we're gonna do 2004. VirtualBox is pretty smart, and as you saw, as soon as I started typing Ubuntu, it was able to pick that up. But there's a whole bunch of OSs and types that you can pick from. You can choose memory size. I'm running Linux on my host machine, so I've got KVM enabled. I'll talk about that in a second. So I don't need a lot of RAM. If you're on a Windows machine, you'll maybe sometimes have to bump this up to like 4 gigs, 6 gigs. This is how we're going to create a hard disk. So basically, if you were to stick a hard drive into a computer, that's what this would be. So we'll go ahead and create a new one. These are just different hard disk file types. They're not really important right now. We'll just do a VDI. I think VDI is VirtualBox proprietary, and then VHD is another standard, and then VMDK is another standard, I think.
VDI is an old Oracle thing that has been folded into VirtualBox.
Gotcha.
VHD is Microsoft's equivalent of that. They're all open standards. VMDK is Virtual Machine Disk, which is virtual. No.
I think it's
what's the word? VMware. Yeah.
yeah.
So VMDK is going to have the most support generally, and it has a few more features. And then if you have, I think if you have QEMU installed on Linux too, you get a few more features on this window.
I have it installed, but
Hit expert mode.
oh,
Yeah,
decal.
there you go.
Nice. Okay.
So those other 3 are all like super open source generic formats.
Gotcha. All right, so we can come back here. We'll do VDI for now. Dynamically allocated versus fixed size. So basically, if it was fixed size and you allocated a hard drive of 32 gigs, it would create a 32 gig file on your computer, which can sometimes hurt. So you want to stick with dynamically allocated. So it'll only take up as much space as the VM needs. So for Ubuntu 2004, I think I've gotten away with 10 gig before, but I'll go ahead and keep it at 32. Depending on your OS, I've gotten Debian VMs down to 8 gig or 2 gig. So this is something that can vary wildly. If you don't allocate enough of a hard drive, I've had VMs just completely fail to install. So you can go out to different distribution websites and check what the minimum requirement is. I think Debian headless without a desktop is like 4 gig or something, but for now, we'll just keep this at 32 gig. Okay, so you can see it created the VM, but if I go ahead and turn this on, it doesn't have a startup disk, so we need to install an operating system. This what we just did basically defined the hardware. So that ISO that I told you guys to download, we'll go ahead and do this manually. You'll take that ISO, it's basically a disk image, and we can come into the VM storage and click this little disk, and then you can find where that is. So we select that, and this is the equivalent of just sticking a USB drive or an install disk into the computer. So we can go ahead and click that and then start. And you can see VirtualBox boots that up. Okay. So now it's asking us whether we want to try to or install. We'll go ahead and install. Just basically mash continue through a lot of this. I typically go with a normal installation. It just gives you some other stuff like LibreOffice and media players. I typically download updates as well as install third-party just because. I also just realized I forgot to mess with the hardware before I booted this, so it might take a minute. All right, so just keep going. All right, so we'll say it's our user. Ooh. We'll call this, no it doesn't. Anyway, so this, you're just specifying your username and then super secure VMs, password is password. And then we'll just click continue. And then that'll kind of do its thing and install. While that's doing its thing, we can talk about hardware stuff. So for any of you following along and or what the hell, that, no. For any of you following along, if you're running on Windows, I apologize if we didn't mess with processors. Like I was saying with the different types of hypervisors, VirtualBox is a type 2, so you have to go through the operating system to get to the hardware. And if you stick with one CPU on Windows, it's pretty sad and pretty slow. So you might want to beef that up a little bit. There's different acceleration types. So if you have Hyper-V installed or KVM, which I have KVM because I'm running on Linux, that's where you would select your different acceleration. And then, as you guys saw earlier, this is where you can specify how much RAM. There's different display settings, different audio. This is where you can mess with your network stuff. So those different network types I was talking about. The default is NAT. This will basically just give you internet access. You won't be able to talk to the VM from your host. So I don't have an IP yet, but if you were to like ping the VM from your host, you wouldn't be able to talk to it. To get around that, you would use host-only adapter. So that's networking. There's different serial ports, USB stuff. You can do shared folders. I don't really use those too much. I've never used user interface, but that's a general overview of hardware. Does anyone have any questions? I know I kind of just flew through all of that. Sounds good.
I have kind of a question. So where you're talking about how, most cyber stuff usually runs, it's easiest to run through Linux, correct?
Typically.
Would you say it's feasible to try to, instead of running Windows, to run Linux instead, just from the ground up? Or
So
well, I know it's kind of separate from virtual machines, but just as a general question.
yeah, no, totally. Yeah, myself, Chris, Cliff's not here, but we all run Linux natively on. I run it on my desktop. I run it on my laptop. So it's very feasible to just install it or erase Windows and install it on your laptop.
You also don't have to fully just erase Windows. You can also just dual boot. So if you have enough disk space, you can double partition. You have other physical drives, you can just swap those out too. Yeah, and then also on Windows, there's the Windows subsystem for Linux now, where you can run it's more of a container than a virtual machine, transparently on your host machine in Windows. And you can basically download different distributions of Linux through the software store on Windows. So that's also kind of feasible. You're not going to have the same control over devices, and you won't really be running. I guess on WSL2 you have the kernel, but it's not quite the same. So you can get a lot farther now than you used to be able to with Windows, but there's nothing that quite compares to just running Linux natively. Because if you want to change anything on the system, including like the kernel, you can just shove stuff in there and recompile it, and then just run off that if you want. You just can't do that with any other kind of system, except for maybe BSD, but that's a lot harder.
Yeah.
As well, if you really needed to, you could run Windows on a virtual machine if you wanted.
Yeah, Windows on a virtual machine with KVM pass-through is way faster than Linux on a virtual machine on Windows Hyper-V pass-through, or acceleration on pass-through.
Yeah, I'll ask. I dual boot off I have a Chromebook, and I dual boot a very, very low level, not just low feature set distro of Linux. But I guess maybe it's just that version that's just very awful, and I didn't know what your guys' experience of just running it day to day was.
Typically,
Which distribution? Sorry, Chris.
No, that's a good question. Go ahead.
Yeah, what distribution is it?
Gallium, which is known by, I don't know, very few as far as I understand. It's basically, it was built to run on Chromebooks. So
yeah, the whole Linux thing on Chromebook has always been very unstable, unfortunately.
Yeah.
I think Chromebook has been starting to have more stuff for Linux on just the regular stuff, Chrome OS, but I honestly haven't been following it for a while now.
Yeah, no, I did a little bit when I was trying to figure out what to do with it last year, and I figured dual booting was the easiest option. But yeah, it wasn't a super great experience, but I figured it's a mature operating system. I figured it's okay day to day. I just didn't know what it was like for you guys.
Yeah, and Josh. So as far as actual distros go, I actually run Linux too, and you might want to think about Debian. So the latest version is actually Debian 10.5. So I would definitely recommend you check that out.
All right.
Yeah, Debian and its derivative of Ubuntu, which is more commercially oriented, are very good for personal use. Otherwise, the other top flavors right now are the CentOS and what's the other one? Fedora. Wait, what?
Yeah,
Fedora. Those are the other major ones right now. But Debian is definitely the easiest family of Linux distributions to use.
Is CentOS derived from Fedora?
I don't remember.
I think it is. I think the two, where the tree really branches, is Debian and Fedora, and then RHEL and CentOS are derived from Fedora.
And really the biggest differences between all of those is package managers and initial configuration and maybe a few other kernel features that you're probably never going to ever interact with through running. So.
All right. Thanks for the information.
Yeah.
Yeah. But to really answer your question, I have 2 hard drives in my desktop, one with Linux and one with Windows. And I run that pretty seamlessly. I just choose which disk I want to boot from Grub when I turn my computer on, and it's pretty nice. So that is a happy medium I found, is just installing it on 2 separate hard drives instead of trying to dual boot and create partitions.
Yeah, the partitions are.
Yeah.
Things can go wrong if you don't do it right.
Yeah. For those still watching this VM, I basically just restarted it and added a couple more cores. So you can see our OS is installed and ready to go. Is there anyone following along that is having trouble or has any questions? Cool. All right, and with that, Chris, do you want to go to Schemaverse?
Sure. Do you have slides?
Yeah. What time is it? Firefox is covering my time.
It's 7:30.
Okay.
Just before.
So, all right.
So we can either start it this week or just do that as our meeting next week.
We can go through the explanation. That
Okay.
way.
Just do the overview and we'll actually dive into it next week.
Okay, cool. All right. Can we see all that?
Yep.
All right, cool. Okay, so for our first big activity, we're going to do Schemaverse. For those who aren't new, typically we go over a different topic each week, and maybe we have a small little activity that we can do. But this semester, since everyone's kind of cooped up at home, I thought it would be fun if we just had a bit longer activities and people got to do a lot more hands-on stuff instead of just watching me go through slides. So the first thing we're going to do is Schemaverse, which Chris and I have known about for a while, but we've never actually played a lot. Chris, I think, tried to set it up a couple years ago, and it was a lot harder at that time. It's come a long way. So Schemaverse, it's basically a space-based strategy game implemented entirely in Postgres. So there's not really a GUI for it. You just have to be really good at writing SQL commands to play the game. We picked this just because it helps you learn SQL, and there's also some Postgres vulnerability stuff. So that's a little bit cyber sexy. So that's what Schemaverse is. We're going to go through a crash course on how to play. It's a lot to take in at once. I went through their tutorial and there's a lot going on. So I think in this next week before we start playing, I recommend going through and reading the user manual on top of these slides, and it'll make a lot more sense. So
there's also an old DEF CON presentation where one of the creators goes through it in a lot more detail.
So at the end of these slides, I have a link to the tutorial as well as the DEF CON presentation. So I highly recommend those. So to start, like one of the core concepts of the game is the tick sequence. Basically, it's 1 unit of time. So I think it's like every minute it'll tick and execute all of the actions that have been queued by different players. That's the command to get the last tick value. Basically just select last value from tick sequence. But this basically plays the game. So it does all of the following, which we won't dive too deeply into. But it basically checks if the game's over, it moves ships around, if you have a fleet, it'll run those scripts. And then if you have ships that are mining, attacking, or repairing, it'll execute those actions. So basically this plays out the game. That's really what the tick sequence is. To win, so basically the game is played in rounds and they last for a day. And depending on how intense the game gets, it's anywhere from 200 to 600 ticks per day. And at the end of that one round, the player with the highest score gets a schema supremacy trophy. So that 200 to 600 ticks per day, basically what it comes from is the tick sequence will sleep for 60 seconds and then execute all the actions that each player has created. So if it's like, hey, mine this planet, it has to execute that. And depending on how many players, that still takes time. So if the game gets complex enough or large enough, if all of those actions take 60 seconds to execute, then really you're waiting 120 seconds between each tick. So the ticks per day can vary. Yeah, trophies contribute to a final score. There's a lot of trophies. If we go to the tutorial, you can see there are a lot, and there are also trophies that contribute negatively to your score. So if you've had the most ships destroyed within a round, you can get 100 points deducted. So you can come and look at all the trophies and see what you kind of want to shoot for. So I guess player with the most powerful fleet, that might be something you want to shoot for because it's 200 points. So there's not really an end in the documentation. I think we would just choose to end it after a week, and whoever has the most trophies, we would say that person's the winner. But basically it's played in 1 day rounds and you just play until you're done. So we'll get a little bit into the entities that are involved in this game. One of the core ones is a planet. So this is the only place you can spawn ships, but you have to have conquered those planets. So when the game starts, each player, or when each round starts, each player gets a planet, and that's where you kind of start off. You can spawn ships and mine those planets. They're the only source of fuel, so you'll find later in the game when you actually have to fuel your ships, you have to get fuel from planets, and you get that by mining. So yeah, each round, so each day, planets are regenerated, and each player gets a starting planet. And I think the size of the entire map changes depending on how many players. So if there's a lot and it keeps growing, the map will keep getting bigger and bigger each round. So planets have attributes, because this is in a database, so each entity is a table, and then they have their columns and their attributes. Real quick, is there anyone here that has never messed with a database before?
I have not.
Okay. So this will be a good learning experience, hopefully, to learn databases. But if you have any questions and have no idea what I'm saying, feel free to stop me and I can explain. So in a database, you have tables. These tables have different attributes and columns. So in this case, it's a planet table, and each row in that table will have all of these attributes. So if you had Earth, it would maybe have an ID of 1. Its name would be Earth. Location is an XY coordinate. So the entire game is played out in an XY plane. So you have Earth would maybe be at 0, 0, right in the center. Conquer ID is whoever's conquering that planet. There's a fuel supply, and there's a mine limit. So however many people can mine that planet, I think, so in case it would be 30 people can mine this planet, then If more than 30 people try to mine that planet, some people aren't going to be able to successfully mine. We'll get into that a little bit later. So that's the planet table. So your home planet is what you get at the beginning of the game. If it gets really out of control, you might check at the beginning of a round and see that you don't have a home planet. That's not the game's fault. That means someone else conquered it before you could view it. That is a thing that can apparently happen. So there's a couple built-in functions and variables. So get player ID. If my username was Aaron, I could do get player ID Aaron, and it would return the ID. You can use this when you're querying different things from tables. There's also the session user. So when you're logged in, session user has your username. And then this is just a query. So select all from planets where you've conquered them. And you can see it returns the foo planet and different information. So ships are another thing that you're going to deal with. They are basically, it's just a ship. So they kind of fly around and attack each other and mine different planets. They have a lot of attributes. I highly recommend reading the documentation, and it'll talk a little bit more about each of these attributes. But you've got different things like health, the last living tick. If your ship's health gets down to 0, this will stop increasing. And then eventually, if it's dead for more than 60 ticks, it gets destroyed and you can't use it anymore. There's also a range, so how far your ship can interact with things. So whether it could like mine a planet or attack another ship, it would depend on that range. There's also attack, defense, engineering, and prospecting attributes. We'll talk about those a little bit later, but basically how strong your ship is or how much it can repair itself, or for the prospecting, like how much it can mine. And then there's a whole bunch of others, so like location, and then destination, direction, speed, all that stuff. To create a ship, they cost 1,000 something. The documentation is not specific on what that unit is. I assume it's dollars. So when you create a ship, you can specify how many points you want to give to the attack, defense, engineering, and prospecting attributes, and it has to total 20. You can see in our example here, they've got 555, so 5 points each. And then this point, I believe, this point has to be a planet that you've conquered. And I think the game will check if that's a valid point, and it'll yell at you if not. But that's how you can create a ship. You would insert it into my ships. So you can upgrade your ships using the upgrade function. This is the general layout with your ship ID, skill, and amount. Here's an example. So upgrade ship 1, it's max health by 1. And then here's a giant table of the cost of things and the limit. The attack, defense, engineering, and prospecting, they total up to 500. So like when we were creating, you only had 20 points to allocate. In this case, the limit is a total of 500 between all 4. Mining, so this is really where you start to build your wealth and like
Hey, Aaron.
stomp on other players. Yeah.
Do you mind if we go into the game mechanics a little bit more in detail next week?
Yeah.
All right, just want to free people up tonight. Do you have any more core mechanics that just need top-level explanations?
Really, mining is the biggest. We can talk a lot more about this next week.
Okay.
If people want to read the tutorial and watch the DEF CON talk, and if they have any questions next week, we can talk about it.
Okay. So just to get everyone synchronized again, I'm thinking next week we'll probably break into groups of any amount, and then we can kind of form teams rather than play as individuals. So that way we can actually like make systems play the game, because you can't really play this game directly without extreme trouble. You kind of have to make it a thing to play the game for you, which is part of the fun. So you get to learn a lot of fun stuff real quick. And if we're in teams, it'll probably go way easier for everyone. All right.
That sounds great. Make sure you did the sign-in sheet and stuff.
All right.
Yeah. Good first meeting, y'all.
Yeah. So does our new people want to introduce themselves just so we all know who everyone is?